Hi students, welcome to videos on control system. In this video we'll see how do we find the transfer function of electrical systems. So let us consider a very basic electrical system having a resistor, an inductor and a capacitor. So this is having a value of R, L, C. This is V in, this is V naught, this is the reference ground. Let us consider a current I flowing through the available loop of the circuit. So we know that output voltage V naught of T is given by the voltage drop across this capacitor, which is nothing but 1 over C integral of I dt. So this is the current flowing through this entire circuit. The drop across the capacitor is nothing but the output voltage V naught of T. But what is I of T, that is with respect to time what is I? So it is nothing but V in of T divided by the overall resistance, So what is the resistance offered by the resistor? It is R. What is okay, now I can write the inductance. Of course this inductor is offering some impedance, this capacitor is also offering some impedance. So okay, let me just before I just complete this, let us write a KVL for this. So if I write the KVL for this, so shall I write it as V in of T is nothing but R into I of T plus, so what is this? This is L into di by dt plus, I'll come to this later. And what is this voltage across capacitor? It is 1 over C integral of I dt. So of course I of T into dt. So now if I take the Laplace of this, so let me just again rewrite. So V in of T is nothing but R I of T plus L into dit by dt plus 1 over C integral of it into dt. If I take the Laplace of this, so then this will become V in of S is equal to R into I of S plus, so we know that a Laplace of a derivative is S into I of S. So it is L S into I of S, and the Laplace of an integral is 1 over S into I of S, that is 1 over CS into I of S. So that now I can rewrite this expression of input voltage as V in of S is equal to, shall I take I of S common factor in all the three? So this is I of S into R plus S into L plus 1 over S into C. This is what is V in of S. So if I want to write the Laplace of this output voltage, I can write, of course I know that V naught of T is given by 1 over C integral of I of T into dt, which is nothing but V naught of S, that is Laplace transform of the output voltage is given by 1 over S C into I of S. This is the expression for V naught. This is the expression for V naught. Then what is the expression for I of S? So from this equation 1, so let us know what is I of S is. So I of S is equal to V in of S divided by R plus S into L plus 1 over S into C. So now what I can do is I can substitute the value of I of S in this equation from this, so that I can write V naught of S is equal to 1 over SC multiplied by what is V in of S? V in of S is, or I of S is V in of S divided by R plus S L plus 1 over S C. Suppose if you simplify this, okay, if I take the LCM, so it is V in of S. So what I can do is, okay, let me just multiply this with this. Will it not become SRC plus S square LC plus 1? This will be the equation. Now can I write this equation as V naught of S by V in of S as equal to 1 over S square LC. Let us put it in the order of S square LC plus SRC plus 1. Suppose if you want to write the coefficient of S square as 1, so that I can take out 1 over LC, I'll take out LC as outside. Will it not become S square plus, it is SRC by LC plus 1 over LC. So now can I rewrite this as equal to 1 over LC divided by S square plus, so does this C go with this C? So is it not S R by L plus 1 over LC? This is what is V naught of S by V in of S. What I mean to say is the transfer function of any given electrical system is defined as the ratio of Laplace transform of the output voltage by Laplace transform of the input voltage. V naught of S by V in of S is the transfer function, which will write it as T of S. Suppose if you say T of S is the transfer function of a system having output voltage, Laplace of the output voltage as V naught of S and input as V in of S, the ratio of Laplace of the output voltage divided by Laplace of the input voltage is nothing but a transfer function. So for that we are trying to get an expression for output voltage in the form of input voltage. For that what we did, we wrote for this circuit a KVL is written for the available single loop by writing KVL input voltage is equal to the drop across this plus this capacitor. So that's what is this expression, and we are taking the Laplace. Here we are taking the Laplace transform, considering all initial conditions as 0. When I say all initial conditions as 0 means, for an inductor we will consider initial current as equal to 0. For capacitor, initial voltage is 0. That means there is no current flowing through this before we actually pass this current, and there is no voltage across this capacitor when we apply this to the circuit. So this is what is initial conditions are 0, 0 for both inductor as well as capacitor. For inductor there is the initial current which is 0. for a capacitor there is an initial voltage that is also considered as 0. So with this as initial conditions as 0, 0, we can write the Laplace of a derivative as s into ifs, whereas Laplace of an integral, that is integral of it into d of t, is nothing but 1 over s into ifs. So we can rewrite this expression as so and so, taking ifs as common factor. Then we are trying to get an expression for output voltage in terms of V in Fs. So we are replacing ifs in the form of V in Fs divided by the impedance of the network. So upon rearranging, we can able to get the transfer function of the system as 1 over LC s square plus s into r by L plus 1 over LC. So this is a standard form of this transfer function of this network, that is RLC network, making the coefficient of s square as 1. This is also true. This is also a true transfer function, but difference between this and this is, here the coefficient of s square is LC, here it is coefficient of s square is 1. So to bring it to a standard form, so we just put it in this way. So we have the numerator as 1 over LC and the denominator as s square plus s into r by L into 1 over LC. Similarly, let us try to find what is the transfer function of some other electrical system. So second system, let us take it as a very simple one. So this is V in of, okay, now let us take it as V in of t, and this is a resistor, this is a capacitor, this is R, this is C. So I can write, of course this is V0. So our intention is to find V0 of S by V in of S. We want to get the expression. For that, what is V0 is equal to, it's actually 1 over C integral, okay, let us consider a current of I of t here. So this is V0 of t. V0 of t is with respect to time. It is I of t into dt. But what is I of t? I of t is nothing but, now we can write V in of t as equal to R into I of t plus 1 over C into integral of it into d of t dt. So now can I write it as, if I take the Laplace, is it not R into I of s plus 1 over C into 1 over s I of s. So can we write it as I of s into R plus 1 over SC is my V in of s. So then what is I of s? I of s is equal to V in of s by R plus 1 over SC. So what is V0 of s? From this you can write V0 of s, again take the Laplace, 1 over SC I of s. I of s is this, I of s is this over here. So now you can write it as V0 of s is equal to 1 over SC. Is it not V in of s into R plus 1 over SC? Can I write it as V0 of s by V in of s as equal to 1 over, shall I write it as, this is S RC plus 1, or can we write V0 of s by V in of s as equal to, okay, this is S RC plus 1. So this is my transformation. Now this is how we can write it. So what we can do here is, instead of doing this all the time, so we can simply again find the transformation same using this same circuit. We will write it as V in of s. We will write it as V in of s. So let us take the Laplace of this. Now let us write it as IFS. Let us write it as V naught of S. Let us write the transfer function Laplace of this C as 1 over SC. So now instead of writing it as, this is actually a capacitor only. Now if I want to replace, if I want to represent it by its Laplace thing, I can write it so and so. So can I now write of course whenever I write it so what is the transfer function? So transfer function output is nothing but, I am just writing the same thing, output is nothing but current multiplied by this impedance. Impedance is this, so it is 1 over SC. What is the current? IFS. So what is IFS? IFS is V in of S divided by overall impedance. Overall impedance is R plus 1 over CS. So 1 over, let me write it as 1 over SC. So now then what is V naught of S? So V naught of S is equal to 1 over SC. What is IFS? It is V in of S by R plus 1 over SC. So now you can write V naught of S by V in of S as equal to 1 over SRC plus 1. So maybe in the coming equations, what will coming circuit, what we'll do is, whenever you have been given an electrical network, replace those time variant parameters as Laplace one. So it is V in of S. Instead of writing it as V in of t, I of t, and this as C, let us write it as 1 over SC as the impedance of this capacitor in Laplace transform. R is the resistance of the resistor. Thank you.